Hello and welcome to another nighttime coding stream. I am Luca and today we will be working on the crystal compiler um, for Brainfuck. Yeah, as you can see, I have up in the terminal what I'm planning to do today. Thinking adding comments to our interpreter, and the reason for this is kind of important, and it's because I am still planning, like I thought about it a lot. I am still planning to write a brainfuck compiler in brainfuck, and hopefully it'll just compile to native, so it'll be self-hosting. And I did say I was thinking of doing it in completely vanilla brainfuck, but the issue is that without comments it makes things really inconvenient, and I feel like adding comments doesn't really help that much with the well, helps with the development, but in a sort of a meta way, and not in the sense that like it's like solving a problem for me. For example, like functions would allow me to um like reuse code. But we're not going to add anything else, just comments, so I can at least keep track of things. And technically I guess I could, like, if I really wanted to stick with vanilla brainfuck, I could write like a Python program or something to just like delete all the comments that I write before compiling in our compiler. So it's really like a non-trivial, or sorry, it really is just a trivial like thing to add, I feel. The next thing I wanted to do was add error checking. This is like a very important thing I feel for this, and there isn't really much to error check. Like I really just want to check for, honestly, like if the brackets line up. That's really the most important thing. The brackets match up, and the reason for that is because and we also want to make sure that it's printing the error properly, and we have an easy way of like figuring out where the error might be. We might add some debug options to like maybe print the non-zero cells that brainfuck uses to keep track of data. um, but yeah, so we're gonna do that. This is important because again, when we're gonna write the brainfuck compiler in brainfuck, um, it'd be good to have like a good way of checking the errors. So yeah. And lastly, if we have time after those two things, I downloaded Phasm. I was able to compile its Hello World program, and so if we have enough time, that's the next thing that we'll be doing. Hopefully, we can get there. If not, we'll do it tomorrow. So let's get started with adding comments to our brain fuck interpreter. So let's get out of here. All right, so I changed the name of our file a little bit. I haven't done anything new in it though, so there's nothing to worry about there. And if we open it up, you can see it's pretty much right where we left off. The only thing that might be different is that I added plugins to NeoVim, so there's syntax highlighting, which will make things a lot easier. The tabs aren't fucked up, so it'll be much easier to develop this with. Okay, so the first thing I want to do is add comments. I was thinking of adding comments in a very like simple way, and here's how comments will look like. First, let's do our typical print a algorithm. So there's 5 here, open up a bracket, 5, and then we'll print the new line here. So I think that should be just fine. Perfect. So now we have our test program again. It's good to go. And the way we're going to add comments is like this. Now, I want to add a little colon here, or a semicolon here, and then say something like, so I'm allowed to do something like this. And to stop the comment, I actually have to do another semicolon. And this is because we're not looking at new lines. And if we did look at new lines, then I would just check until the end of the new line. But since we're not checking for new lines, I've decided to just do comments like quotes. So this is how we're going to do comments. There you go. Let's go ahead and add functions. Or let's go ahead and add comments. Oops. Okay. So to add comments, that's as easy as adding another when statement here. So let's just go ahead and do that. And here we can do it until, which is kind of cool in Crystal. You get an until. What's happening here is basically, I'm basically going to check, or I have to increase the pointer. So let's do that. This one. So once we get into this, into here, and if we're looking at a semicolon, then what we want to do is we want to skip everything in between until we get to the next semicolon. So here is until the data pointer is pointing at a semicolon, then, oops, sorry. This is until program at IP. We're gonna keep just skipping. So do that, and then once that's equal to the semicolon, then we'll be right on top of it. So we want to just move to the next instruction, and so that should pretty much be it. That should be the entire implementation of comments. It should be that simple. Let's compile. And there we go, and let's give it a shot. I okay. Let's see what went wrong. Just by looking at it, hopefully we can figure it out. Okay, let's see. Maybe adding numbers does something different. Nope, that's fine too. That's interesting. Why did it break the first time then? Because if I do this on A, oh, it was just fine all along. I don't know why this happened. BF. Oh, okay. It's because I gave it the completely wrong file. Okay. So everything's working fine. It was working fine right from the beginning. Okay, great. Cool. Let's delete that guy, and let's also delete that guy. Okay, and the only thing we have left is perfect. And just to make sure that runs just fine. Alright, that's the wrong instruction. Perfect. Okay, cool. Now the next thing I want to do is I want to check for matching braces. And to do that, I won't be able to simply run everything in line like the way I'm doing now. I have to write an extra loop to do these errors, because right now I'm just doing everything in line. So what's happening is what I need to do is I need to find a way to report these errors without already starting to interpret the program. So this isn't like Python where as the program is running, it'll report an error if it happens. What I actually want is if I like right before I write any code, before anything is printed at all, I want it to actually make sure that the program is correct. So it does a compile time, static time check that everything's fine. And the reason for that is because the machine code needs to be properly written like that, in that way. Hopefully that makes sense. Okay, so let's get started. So because I want to keep this as simple as possible, and because I'm going to be writing in Brainfuck later, and I kind of want to be able to sort of, what's it called, translate this code to Brainfuck later. It's going to be very, obviously very like obfuscated, but I want to keep this code as simple so it's as easy as possible so I can translate it over. So what I'm going to do is I'm just going to do another, I'm going to just straight up do another loop here. And I'm just going to run through the program first. And as I run through it, I'm going to check for some errors. So one of those errors is going to be not matching braces. So let's do that one first. first, let's put the OP in here. And there we go. Then what we're going to do is make case OP. And so this only matters for this case, for example, when we open the bracket. And if we check an open bracket and it has a closing bracket, then we know the closing bracket's fine. So we only need to check it for the open bracket. If it closes, then we're good to go. The next thing we need to do here inside of here is look for it. So it's going to be very similar to the code down here. We have to keep track of the open brackets. So let's do that. And we also have to keep, we don't want to move the actual like index in the program. We want to move a different thing. And yeah, so let's, IP is going to be here, and that's going to be set back to 0 here because we're going to reuse it for this loop. All right. Oh, and we have to end that. There we go. Cool. So let's do this loop here. We have to keep track of the open brackets, which right now we're at 1. And we also need to keep track of the current index in the program. So let's call this IP. Let's call this just I. And that's going to be IP. And I think maybe I can't remember what I have to do for and here, but I think maybe this. So as long as the index on the program is less than the program size, we can keep going. And if its open brackets is open brackets is greater than 0, then we do the while loop. Inside this while loop, we're just going to go ahead and add +1 every single round, and unless we want to break out. And here we check if if the instruction at the ith index of the program is an open bracket, then we once again want to do open brackets equals 1, and we add that, and we do an else if here. If the program at I is equal to the closing bracket, then we move this back by 1. Okay. Something else that we want to do is actually keep track of the line numbers. That would be kind of useful. So once we find that, once we break out of this, over here, we check if open brackets is equal to 0, then that means we're good to go. So it's only really if it's like that. If it's like that, then what we're going to do is just exit immediately pretty much. And say, and let's write an error here. Let's say so if the brackets aren't equal to 0, then that happens. And we also want to keep track of the lines. So let's do that. Line is equal to 0. And every single time, every single time we get this, we're going to add one line, and that's it. And we'll start this at 1, so it's easier to know where it's easier to tell when it prints the error. So that should be pretty much it. If we end up finding the something else we have to do is keep adding 1 to the IP. We keep moving through the program, but basically that's pretty much it. Here we keep track of the line. Here we check for the open brace, and then we do that check to see if there's a closed brace, and that's pretty much it. We don't really need to check if comments close, because if it opens up and it doesn't close, then the rest of the program, it just doesn't run, and that should be pretty okay to catch. Also, because I'm adding comments to Brainfuck, I am also the compiler that we write in Brainfuck with Brainfuck. that will also allow for comments, because what I actually really want is that compile to be able the brainfuck. What I really want is the brainfuck compiler written in brainfuck to be able to compile itself. And so it will have to be able to recognize comments. And so the more I add here, the more work I'll have to do in the brainfuck compiler, and I don't want to do a lot of work there. Okay, so again, also one other reason this could probably be somehow refactored out into a function, because I'm doing very similar things here. But again, because I kind of want to make this very easy to translate between Crystal and Brainfuck, I really want to make it so and since Brainfuck doesn't have any functions, I just decided to I'm gonna have a preference over repeating code over refactoring into functions, just so it looks more like Brainfuck. Pretty much, that's pretty much the reason why I'm just kind of repeating code. I think that's pretty much it. If we get to this will just exit out of the entire program if we get an error, which I think is fine. We're not going to look at anything past that, because anything after that, I feel like it shouldn't, we should fix them one by one anyways. And I don't really want to go that much further into error handling. So let's just see if this works. Whoa. I totally forgot that I had to do that. But I really just did that. But at least it compiled. That's good. So we'll clear it, and now let's copy this guy into here. So this will be an error one. This is going to be an error one. So let's open up let's open a couple brackets here, and let's not close one. And let's put them all on different lines, just so it's easy to get the error for it. So we're compiled. Let's see. We should just get an error. No file to compile. Whoops. Cool. The open bracket at this line was not closed. Okay. And if we check line 2, let's go there. So line 2. There we go. Sorry. Line 2. So I guess right over here. 1. Yep. So this, oh yeah. So this doesn't close. I see. So this one closes with, so what will happen is that this will go here. It'll open up a bracket, open. This one closes with this one. It thinks this one closes with that one. It thinks this one closes with this one all the way down here. And then here it tells us, oh, this bracket wasn't closed, which makes sense. So cool. So now we can delete all that. So now we get error handling, and now we're kind of done with the Crystal version of the compiler, and we're with the interpreter at least, and we're just getting started with this video. What am I doing? I just want to remove, oh, B. What am I doing? I'm like trying to delete something that doesn't exist. All right. So we're done the first two things that I wanted to do, and let's just look over the compiler real quick, and let me just make sure it has everything that I wanted it to have. So we have the options here. Something I do want to do is I want to make these options a little bit easier. I'm actually going to change this to just interpret. Yeah, just I, because I wanted to specify that. And now we're gonna have a different option for compiling. I'm gonna add a new one here. Where I forget. Interpret given source. Compile given source. Cool. And now we will do the same thing we do in the other one. File path. Done. Cool. So now we have two modes, but we also have to set the mode. So let's set the mode here. I don't think we actually need this. I think about it. Let's set the mode. We can actually just set the mode here. We don't have to set it outside, I don't think. So we can set the mode right over here. Roll. Switch right over here. Let's do a crystal build. Undefined method interpreted for run mode class. This is not how you do enums in Crystal. All right, let's do a quick googly Google. That's how you do it. Okay, I see. It's just a different way of getting it like that. That makes sense. Okay, let's see if that builds. Puts mode. Undefined variable mode for top. Okay, so let's build it. Great. It's clear. And let's see if how it works. So let's do I on AWF. That should do that. Interpret, perfect. And if I do it on C, still interpret. Nice. So it didn't change anything. Something's broken. I guess let's do it the way they maybe want you to do it, which is with the dash, I guess. Does that work? Give it a little compile. And then let's give it a little run. So it's still interpret, which is weird. Because the C, oh, it's because I'm not running it the way it's supposed to be. Okay, there we go. So it does want you to do like a dash. You can't just like put anything you want. Okay. All right, so now we have two modes, interpret and compile. And now let's check. Let's go back in here. And let's delete this. There we go. We're only going to have a compile version for the brainfuck version of this because all you really have to do when you do that is when you encounter a loop, for example, or an operation. When you encounter a byte, you can just emit immediately a machine instruction, which will then be compiled with assembler, and then that will be the thing that runs. But if we decide to interpret it, then we're the ones that have to keep track of the stack pretty much for it. So it has like a data pointer, and we'll be the ones that have to keep track of that data pointer. Whereas the assembly x86, the language, the assembler will be the thing that does that for us. We just have to write out the instructions. So it should be easier to actually write brainfuck, the compiler, in brainfuck as a actual native compiler than it should be to do it as an interpreter. I guess we'll see. Well, I guess we'll find out. All right. So finally, let's put, since we're not gonna have even an option, like a way to do options, we're just really gonna, the way we're gonna pass, because brainfuck doesn't have a way to open files in like the normal version, we're gonna actually have to just stream it in through standard input. So we'll have a slightly different way to compile brainfuck in that version, because we'll need a way to know when the person has, like, the file has stopped, and we also need to know like other things. And so we're not going to really have like an options for it. It'll really just take in a brainfuck thing, and it'll output the assembly for it, and that'll be how we compile it, because there's no way to call any like functions. There's not really any like good way to do that. So yeah. So let's write a function here, and this function right up here, we're going to call this one interpret. And we're just going to copy pretty much this entire everything from here on out, here down, right here. This is the data, and this is the IP. So really, yeah, all this will be copied. We don't need to do anything else aside from, you know, so since there's no like let statement to say when we're declaring something, an assignment and a declaration look the same, we don't have to change anything on that area. We don't have to change anything here, nothing here. What we do need to do is have it input the program, and I think we'll do it like that, which will be a string. So it'll take in a string as a parameter. I think that's actually all we need to interpret it. I don't think we need anything else. It's a very, very simple program. Okay, so let's see if that runs fine. So let's do here, interpret strange, and yeah, that's fine. Let's choose. Seems like this is fine. Interpret, and then we'll put in the program in here. Program. All right. Now let's compile this. Error space required before colon in type restriction. Interesting. So does it want me to do it like that? Like this? Is that how? Let's check. Huh. Okay. That's really interesting. That's really interesting that that's like a compiler error. But okay, sure. So now we're just gonna check if this just runs like how it should. Yep, that seems fine. Perfect. And now we're gonna go back into here. Add 4. If mode is equal to run mode. Interpret. Then we'll do this guy. Otherwise, we'll check if it's equal to compile. And this is not implemented yet. And then we'll do an else as well, just to say, like, there's an error that happens. Put s. And we'll put a little assert in this. Assert false. Okay. Now let's see if this compiles. Crystal build df false undefined constant. Okay, so it didn't catch the assert as it, but I think maybe that has to be in lowercase. Not, I keep thinking it's like Python for some reason. So there we go. Yeah, and I had the color highlighting. Assert. Okay, so there's no method assert. Okay, let's look that one up. Yeah, I'm not sure. Yeah, okay. Well, I'm not gonna waste too much time on it. Yesterday, I spent way too much time just looking stuff up, so I'm not going to spend too much time on that. Instead, I'm just going to put not implemented yet, and we'll return here. All right, so let's compile this guy. Perfect. And now let's try to compile something. So if we try to build this one, fine. If we try to do this, not implemented. All right, perfect. Now we can start writing the native version of this, and it should be pretty easy. But since I've never ever done that before, it's going to be a little bit like it'd be easy for someone who does assembly programming a lot, but someone who's never done it. I think I did it just once in university. It'll be difficult. So let's get started. I already downloaded Phasm, and something cool about Phasm is it comes with these cool examples here. I already tried compiling the exe here. Here's the Hello World program. It just came with the Hello World program, which is like the nicest like thing to do. It even came with like a little thing here to tell you where to find syscalls, like a little comments here. It comes all set up for you, readable, executable. This comes set up for you. You have an entry point here. I actually don't know what this means, so I'm gonna maybe look that up, or I might not even look it up. I might just kind of scuff this. So yeah, so it looks like this message. This is like where you create like these constants. I'm guessing there's like a constant section. Readable, writable. Yeah, that's what it says. Like there's like a segment here. I've seen Tsoding work with Phasm before, so I get like the very gist, but you don't actually like understand how to program something until you actually sit down and do it. And so this will be like a little bit of a challenge for me, since I really don't have like any idea what any of these, like I don't know what any of these things mean. Like EDX, like I don't know what this is supposed to be for. I think it's a register where they're probably putting something in for what, for a write call. So I think EDX is like maybe the next. Yeah, here we go. So EAX is okay, that's the third. Okay, so the third parameter I think is maybe the length, I guess. Yeah, I'm not really sure what this is doing, but oh, it says right here. I'm not even reading it. CPU 0 extends 30-bit operation to 64-bit operation. Okay. Oh, I see. So they're using, they want to use EDX because it uses less bytes than RDX. So this is going to be a smaller operation, but technically this could be RDX and it should work fine. I'm going to change to RDX because using EDX seems like an advanced move to me. But first, let's make sure it compiles. So let's move up to here to Phasm. Let's actually just start. Let's actually just generate this file in Crystal first. So let's first open up Brainfuck, and now we're here to compile. So here we can actually just print stuff into how do I split my screen? I forgot how to split my screen. How do I split? Control W, Control S. Okay, that's literally exactly what I did. Okay, there we go. Okay, cool. And I should be able to move back and forth pretty easily. And this one, I will open the assembly. Cool. So in this version here, we're just gonna type everything out. Oh, 64. I find doing this is actually helpful for like kind of like understanding the language more, like typing it out again instead of just copying and pasting it. So we're really just going to go one by one. Let's make this I want to make it start at 0. This is a generate data function, so it should be that way. And let's do Phasm, hello, XM, and let's do hello. So, oh, okay, so it compiled. I think it's fine. I think that's all I really wanted to check, that if it would compile. And so let's split the screen again. And this is hello ASM. And that's fine. Okay, cool. So everything compiled, that should be fine. And now everything that we're gonna produce will be in here. So it should be actually not that bad, because we have a way to just write out 1 byte at a time, which is what we're doing, and we have a way to and we have a way to read from cells and write to them. So it's really, honestly, so should be pretty straightforward. So let's do a case on the program. Let's do a while loop here. Let's, before I do any of this, let's make sure this compiles. So after doing this, actually, I'm gonna do this. This is gonna be file path, and that's gonna be the string, because I want this to be in there. So take this guy out, and there we go. Put this guy up here. Path. File path. So, and then we're gonna do this here. Cool. And once we finish that, we'll go into here and we'll actually run some command line calls. So crystal lang run. 1 second, I'm getting a phone call, so I have to be right back. Okay, so that was just a phone call I had to take. So let's go back to this. Oh yeah, we want to search up command line crystal lang call command line functions, because I want to call phasm now on that. Process. Here we go. Execute. Okay. So it's in the class process. So what's the, is there a way to, okay, so it's literally, how do I, okay, it should be pretty easy. Process, and it's in the process.cr. So let's, I'm hoping you just have to do that. And then here, process dot, what was it? New change root execute. Where is it? Execute exec, and it'll just be the command, which will be phasm and the arguments will be, this should be pretty good. Well, I guess I'll actually just do everything in here. So this will take in the, and this is not particularly cross-platform, but that should be okay. So this will take in the, and now let's finally see if we can do some string manipulations to remove the ending thing for actually it doesn't really matter, because we're not even gonna, I don't know, we'll keep the, yeah, no, we'll keep it. So we'll just call it .asm. We're just gonna be super lazy. I've decided. Path file path .asm. Oops. .asm. That's okay. And then let's go. Whoop. Take this up. And then that's it. So we're gonna go down here, and we're gonna call phasm on our new path here, and that's kind of it, I think. We can also put the output here, which I kind of do want to do, and to do that I have to take off the last two. Let's actually do that. So I'll take off the last two extensions that we added. So crystal, you know what? The output file, I give up for now. I'll figure it out later. It's getting late and I need to finish this soon. So the output file is going to be path out. So it'll just be very long. And so now let's see this work. This should just work. It should compile. Oops, okay. No such file or directory, file not found. Error executing. Okay, it's because that entire thing isn't I can't just put this entire thing in here. It has to be, I think, like that. So let's build. Has to be an enumerable string. Okay. So let's do that. So this would be, I think, like this. And I need to put these in quotes. Oops. Jesus Christ, I keep pressing enter accidentally. And that will go there. Okay. So let's see if that works. Build. Explicit token expecting there. Oh yes, because I don't have a comma. Totally forgot the comma. And now finally, reserved word as symbol. Interesting. Okay, so I think it's because I'm not doing I see. It's because I didn't put a new line here. And that was messing it up, and I probably need a new line here, and a new line here, and a new line there. So let's build that again. Clear that and run. Okay, so now it has built us where is it? An a.bf.asm. And that should print, that should do nothing. It should do literally nothing. Okay, so let's delete it. It's kind of annoying to have there bf.asm.out. Remove a.bf.asm because that's just regenerated, and we'll keep hello. We'll keep this guy template.asm. We're gonna move this to and we're gonna move hello just to clean this up a little bit. Okay. And that test is what we're gonna actually try to run first. So let's finally get into programming. I really need to. I'm gonna have to get used to streaming because I'm going really slowly and I'm just getting stuck on random things. Okay, let's see. CR. Okay. So in here, now the first thing is we're gonna do a case. So if we're gonna do a whole while loop. So IP is gonna be equal to 0. And while IP is less than program.size, we're going to end. And here we're going to do case. So case on program. Actually, we'll do OP here. So OP is equal to program IP. And we're going to do case OP. And when, okay, let's start with plus. That's the first one we have. Plus will add 1 to whatever so plus will add 1 to the location that the data pointer is pointing at. So add 1 to where cell I is. Yeah. To add 1 to where the data pointer is. Yeah. So there we go. Cool. And here we will actually do that. So the first thing we need to do is we need to put whatever is in cell I into a register. So we'll do that, and it's going to be a whole word, a whole 64-bit word, and we're going to put it into RAX because I think these are all general purpose. So I'm just going to put it into RAX, and if that's not the right way to do it, I'm sorry. All right. So RAX to point to what? Cell I. Okay. So this will move whatever's in cell I to RAX, which is good. Then what we're gonna do is we're gonna move whatever is in into RBX. We're gonna move the actual location of our buffer. Then what we're gonna do is we're gonna add we're gonna add to RBX RAX. So this is holding so RX is holding the value of whatever was in cell I. I think that should be fine. I think this is how it should work. Actually, this is pointing to the so this is pointing to the address. This is going to be pointing to the value. So whatever value was in cell I, that'll go into here, and that's a whole 64 bits, and I'll add it to RBX, which is cells. Okay, so cells has we're now at the right cell to add one to, and we can simply just do this now. Add to RBX, we want to add 1. So to this, we want to add 1 to RBX. I think that's how you do it. The value in RBX, we want to add 1 to it, and it's a byte. We want to add it to a byte. So let's do that. Does that make sense? I think so. I think so. I think so. So, move the location, the value of cell I into, or actually that's not what we're doing. Yeah, the value of cell I into, yep, yeah, that's fine. Then we're going to move the address of cells into RBX. Then we're going to add the value of cell I into RBX. And then we're going to add 1 to whatever RBX points to. And I think that should be good. The next thing we want to add is the dot operator. And that one is going to be the system call that we have to do with the print. So for that, we're just pretty much going to copy and paste what we saw before. So let's go into here and let's do held template ASM, and that has the syscall stuff. Cool. So let's go back here. And what we need to do is file.print here. So we want to add. So the first value is, so in EAX we add 1, RSI we have to put the address, and in RDX we put in the size. So let's do the address first. So RDX, move RDX, we're going to move 1 into RDX. Cool. 1's going to go into RDX. Done. I need to print. This is going to be a print. Print byte at DP. So we're going to move 1 into RDX, because that's going to be the size of the message. And then we're going to move, and then we have to, okay, so actually what we have to do is first print move RAX. We're going to move cells into there to RAX. So this is a little bit different from what we did last time. And then what we're going to do is we're going to move to, we're going to get the word from cell I, and we're going to put it into RBX. Cell I. And so that's that. Then we're going to have to once again move. There's probably a much more clever way of doing this. Like I could probably store a pointer inside of inside of this in cell I, instead of having an index there, I can just put a pointer, and that would make more sense. But maybe we'll fix that later. Now that I think about it, so RBX. So we're gonna add to RAX. We're gonna add RBX to the to the value, the byte value of RAX. We're gonna add RBX, which is whatever's in cell I. All right, so now what we have in RAX should be the beginning, should be like the thing we want to print in RAX. And this is probably taking a little bit more instructions than I have to, because I'm not really thinking about which registers are using for what. But I know for sure that RAX is used for the system call, so I need to have to move whatever's inside there to the actual where the actual thing will live, which is EDI, I think. Actually, no, RSI. So inside RSI, I'm moving RAX into it. Then after that, inside of here, we're going to move the STD out to EDI, and we'll just use RDI because it's a little bit easier for me to understand right now. And let's do move RAX. We're gonna move 1 into there for system right, and finally we're gonna do the syscall. Okay, so that should do it. That should print whatever is inside the value at cell J. Cool. So let's do that. Let's just make sure this works. So add 1, I want to do that. So add 1 to DP where it's pointing at. Actually, I don't think I need this anymore. I kind of understand what I have to do. So from here, what we have is add 1 to where the DP is pointing at. So we move whatever's in cell line to RAX. We move the pointer to cells to RBX. We add whatever is in cell I to RBX, and then we add 1 to the value of RBX, which is whatever that cell is holding. So that's fine. This works. This seems like it should be fine. Here we have, also we should put an else in here, and we'll for now we'll just put s not implemented. Things will go wrong here. Okay. So here what we have to do is we move the pointer to cells to RAX. We move the value of cell I into RBX. We then add RBX to whatever's inside RAX. So now we're pointing at, so it's pointing at something else now. It's pointing at whatever cell I is pointing at. We move the actual value. So did we even put in the right RDX? Here it is, right? So this is where it is. So in RDX, there we go. So in RSI, we put in the location of the string we want to print. In RDX, we put the size of that. In RDI, we put in the STD out that we want to write to STD out, and in RAX, we put in the system call we want to call, and then that's it. So let's compile and run this, and if this runs, then we'll be done, and next time we'll actually finish up building the compiler in native. So let's build it. Hopefully it builds just fine. And moment of truth is when we run this with this, and we do it with a.bf, not a.bf, let's do test.bf, because that's the one that we care about. And it's stuck because we didn't increase this pointer here. So let's do that. And we'll do it in here like we did for the other ones. Okay, there we go. And let's build. And let's clear, and let's do that. Not implemented, this will go wrong here. I think that's probably like a new line or something. Operand sizes do not match. I actually don't think I need to put that there now that I think about it. So I'm going to take that off. I think I don't need to do this. I don't think I need to do this. I don't think I need to do that. I think I could just do it this way. So I'm going to try it this way. And if this works, then we'll finish up. Let's build it. Okay, so it like wrote something. And now let's check it. It is in test. test.bf.asm.out. Oops, nope, it's just .asm. Okay. So we have that. We have add one. So here we do, we basically have a bunch of add one instructions. And that should be 65 times. And then down here we do the print. And it's pretty much that straightforward. Let's see what happens when we call this function. And if it doesn't work, it's getting a little late. We'll have to figure out, we'll have a debugging section next time and finish this up. So let's do that. And it didn't do anything because I fucked up something, and oof, it's going to be too long to figure this out now. So thank you for watching. I think that's going to be the end for today. I'm sorry we weren't able to like finish something complete. But I wasn't able to figure this out, and I got distracted along the way. So next time we will finish up the compiler for Brainfuck in native. And we are live. Hello, hello. Welcome to my third ever late night recreational coding stream. Today we'll be working on the native compiler for our Brainfuck and our Brainfuck that we're making. We're making a compiler for Brainfuck, and it's going to be compiled into native code. So last time we weren't able to actually finish that because I pretty much had no idea how to use FASM, and I also never written in x86 64 code, or assembly, so it was very difficult to get started. I haven't done anything since yesterday. I really just, all I did was delete a bunch of like temporary files I created, and yeah, so yeah, let's get back into it. Let's try to write a compiler for Brainfuck in assembly for Linux. Let's try to do that, see where it takes us. Hopefully today I'll be able to actually finish it, and since it's been a day and I've been able to take a step back, it shouldn't be too bad. Alright, so let's get started. So the first thing I want to do is actually go and look at our template assembly thing. Here what I want to do is just do kind of like a sanity check on how to manipulate bytes in this language. That, and let's run. What does this say? Usage. Okay. Path and elf. Let's open up .cr. And let's finally get started on this, and we're going to split the view vertically, and so I can see my template.asm here. Okay. So I guess I also want to, there's some indentation here, which I think would be nice to have too. So I'm going to quickly do that here. Actually, up here we need to, or before anything, I realize inside this like file entry, we're gonna make a couple. Okay, we're gonna make a couple helper functions, because one thing we need for sure is a way to add this new line here at the end, which we need pretty much for every single thing we type. So we're going to create a new function here. We're going to call it add instruction, or sorry, sure, print instruction. And it will take in the file, which will be file. And it'll also, can I actually define this inside? Is this possible to define inside of the compile function? Because that'd be kind of neat and kind of useful. Then here's what we want, is the line we want to, so let's do that. And does this compile? Can I write commands down there? I don't want to close this entire thing, so I'm just going to go ahead and don't know the key, the bindings for this, so I'm just gonna, actually, before I do anything, I'm gonna look this up. Cool. Okay, so let's go ahead and compile. And this is also very small now. Cool. There you go. And let's go ahead and build. I'm actually going to write a quick. Actually, no. We'll do. We're not even going to bother doing this because I realize that I have no idea how to write bash. So we're not even going to bother, and we're just going to painstakingly write this out like this. Shouldn't be. It's not painstaking. It's pretty short, actually. You can't define def inside def. Is there a way to do local functions in Crystal? So let's try to make a proc. Yeah, why not? Let's try to do it. So here's using the block syntax. Yeah, captured block, which creates a block which creates a proc from a captured block. Yeah. So you can put in a block into this and it'll create a proc from it. But the blocks and procs are not the same thing, despite it sort of being similar, I guess. So let's just copy and paste this guy. And instead of, whoa, it went all the way back to this. Okay. So instead of, oh, I just remembered that I already have it open. But instead of calling this, doing this with def, we'll actually just create a new proc. Oops, I have to do shift. There we go. Okay, and the proc will take in file and line. And here, I don't know why I did that. This will take in file and line. And here we can do file.print. And here we'll do their cool hashtag syntax, pound syntax, I guess. Here we'll put in line, we'll put in the \n, and then we'll be set to go. And I think we have to set this to something. I'm gonna call this print. And I guess that's it. Let's see if this works. So I'm gonna just test it with, I'm gonna test it right here, right under this in this entry point section. I'm gonna do print, and actually we also need an indent size. I want to add an indent size. So let's do that. And it'll just be a U8 innate, yeah. U8, and in here we will, what should we do? This will be the indents. Okay. And now I want to figure out how to add indents to, I guess we could use printf, right? But instead of doing that, I'm going to take the easy way out and simply do an until loop. So while, oh no, till, and then is less than or equal to 0, then we're going to do the following while print, and we're going to add a space. We could probably use like a string builder or something to do this, and it would probably be faster, like much faster, because this is doing like a system call every single time we call print, which is pretty slow, and we're adding one character every single time. But right now I don't really care, and I just kind of want to get something working. I don't feel like learning the syntax of Crystal to figure out how to add a bunch of ones or a bunch of spaces to the beginning of something. So indents -1. Okay. And down here, yeah, so we actually need to call this function print. And if we call it, we will actually, we can't even call it print. We'll call it, what should we call it? What should we call it? Command. No, instruction. It'll be called instruction. Perfect. And then down here, instruction. Why is it doing that? Am I missing? I don't know what I'm missing. I don't know why it's doing. I guess we'll find out when we compile. Okay. So inside here, we can put in the file. We can put in the program. The file. We could put in the line that we want, which is going to be. If we look to the right here, it's going to be move cell I to 2 cells. And this is going to have an indent of 4. Actually 1. And instead of spaces, we will do a literal tab. Okay. So let's see if this works. It should just, it should compile. Okay, unexpected token 1. Instruction. Interesting that it doesn't expect it there. Maybe I need commas. I thought you didn't need commas. I thought you could just do everything space separated, but let's try doing this with commas. But I'm pretty sure you can just do it this way. Yeah, oh, no. uint is not a type. Oh, great. Let's change that. Great. Let's compile. New. Wrong number of block parameters. Given 3, expected 2. Given 3, expected 2. So I'm guessing this is the return value then, right? Yeah. This is the return value, it seems. We could also, we can just use this syntax. I think that syntax is better. Or we could use this syntax too. Yeah, we can do that as well. We could actually even do it from create one from methods, which is interesting. That's interesting. Cool. You do a lot of stuff with this. You can specify receivers. It's really interesting, huh? I didn't realize that. Accepting accepting 2 arguments, 1 and 8, and 1 string, and returning a character. I actually don't want this to return anything, so go ahead and close that guy. I actually don't want this to return anything. So I'm gonna put, I can't remember if it's void. Is it void? I guess we'll find out. Let's try building again. Instruction. Undefined method instruction for top level. Give me 1 second. Give me 1 second. Someone's at my door. Okay. Back. I just need to answer the door real quick. So undefined instruction method. Didn't I not call this instruction? How do I, oh, you know what? It's probably because there's a specific way of invoking this that I haven't I haven't looked into it. Yeah, I have to use this call. Yeah, call. And then I have to, I think I don't have to put in the, yeah, I shouldn't have to put in the brackets though. I just want to try without the brackets. 'Cause that was like a thing that I noticed with crystals, that you don't have to put in brackets. So where is it? Instruction dot call. Does that work? No overload matches that. String I32. Okay, so I guess it doesn't like, let's do int32 instead of U8. I guess it doesn't like something like that. It's an automatically converted, which is weird, but whatever. Or maybe there's like a special way of denoting it. Denoting it's like a byte. Okay, so I have to put U8. I have to put underscore U8 for that. Like, it's interesting. Cool. So let's try to compile it again. We finally compile, and now I have to run it with our C command, and we're running it on test BF. Right? Illegal instruction. How do we do string interpolation? I totally forgot that. String? Will you tell me how to do string interpolation? Okay, so it's the curly brackets. My bad. My bad. My bad. My bad. My bad. Okay, it's good. And oops, I totally forgot to compile this. Boom. Run it. Okay, so we compiled it and it did something. Compile, and now we'll check test.asm, and we will see here. Cool. So it has moved that. It has done this. Has done that, which is good. It added the new line, which is good, and that's pretty much what I wanted. So that's good enough for me. So let's go back and now replace all of the calls we had before with that. And I guess to do that, I will I haven't even compiled it, but let's quickly also add this instruction here to this instruction here. Okay, and now let's call build. And now let's call our compiler with this, and that's fine. And if we open up testbf.asm, everything should be indented. That's weird. Okay, so let's go back here and see what we're wrong. You know what? I'm trying to like find it that way when it would be just faster to do that. So indent is equal to 1. Oh, it's because we're minusing 1 here. That's why. Yeah. So we need to copy it. Done. So it doesn't always set to 0 every single time we call that function. Let's see. Okay, that's good. And now everything is how it should be. Great. Great. There should be 65 of these because it's definitely not optimized. Look, it's just adding 1 to RDX, which is funny. Okay. So now that we've done that, we can finally fix the issues that we had with our assembly code last time. So let's open up our guy again, and let's split the window in half, and let's make this guy the template.asm and see how. So this is the first thing we needed to just kind of initialize everything. So I'm actually going to put in a new line here, new line, and I'm also want to put a comment in here. Oops. Cool. Initialize data. All right. So if we go here, what we want to do for the plus is that we want to add 1 to cell I, and we've already done that. All we have to do now actually is we can delete all this. Oops, just except for that last one. And instead of doing move here, we're going to do add. And instead of doing keyword here and racks, we're going to do cell I here. And we're going to add 1. So that's exactly what we're doing. That's exactly what we're doing on this side here, as you can see. So here we set that up. So if we did that up here, next you can see this cell's address inside cell I. So that's good to go. And here we're putting something inside cell I, so we have to move it to RAX. Okay. So we added 1 to cell I. That's good. Or actually, we can't. It's not we want to add it to cell I. Is it actually? Yeah, it is. No, so this is adding 1 to the data pointer. So actually what we want to do is we want to add 1 to whatever's in here. Yeah. So add 1 to whatever this is pointing to. So this will add 1 to the address of cells, but what we actually want to do is we want to add 1 to the value in whatever is in this. And I think that makes sense. So this is adding 1 to the data pointer, which we can actually just implement this right now real quick. Add 1 to DP. That's that. And then we do instruction. Call. Add. So this will add 1 to our data pointer. And the other thing we need to do is add that new line just for readability. Okay. And we could also easily do the decrement data pointer instruction. So we'll do that as well, and we'll just copy these instructions and put them down here. Sub 1. And I think there's an instruction to sub, so we'll do that. Done that. Cool. And here, instead of adding 1 to this, which is what we're doing when we increment the data pointer, we actually want to get the value of whatever is in cell I. So to do that, we actually want to move cell I into RAX, I think. So into a register, pretty much. So move into RAX. I want to move in the value of cell I. And the value of cell I will be the pointer to a pointer somewhere inside of cells. So we'll close that. That should be fine. So now RAX is holding the pointer to cells. And all we have to do now is do an add on that instead. So add 1 to whatever this is pointing to. And that should be it. That should be it for this plus instruction. The minus instruction should be the exact same, but for now I'm going to leave it out and just test if this works. Add 1 to DP. So I think this all makes sense. We don't even have any increment decrement instructions. So yeah, so now just to be totally sure, I'm gonna go ahead and compile this. Great, that's cool. It compiled. And now, moment of truth is when we do this. C best.bf. Operand size not specified. Gotcha. So this is where I have to specify that I want to add a byte. So here, RAX. Add one to RAX. This needs to be a byte. Build. Clear. Run. Okay, compiles. Let's check the assembly for it. SBF.asm. Move cells. Add one to this 65 times. And here at the bottom we have print byte at DP, and here we have, that's it. I think that's, actually we haven't even fixed up, have we fixed this up? Print byte at DP. So here's another thing, we're putting cells at the top, which is what we don't want that. Actually this is the, yeah, this is the we don't want that. That's actually a mistake. So let's go into here. Oops, I went too far down. So let's go into here and print byte at DP. So the first thing we'll do is we'll move the value of cell I into RAX. We'll move the value of cell I actually into, where's the, what I need to like system to do the system call? I don't remember. To do a system call, we put the size first. So we actually don't need to do much here. And also forgot one important thing in these. One. And up here as well. Let's see this one. Okay. Keep that at the bottom here. And we'll add just a little extra space to make this. Okay. Just so we can like separate the sections a little better. Okay. So this should be actually a much easier instruction call. So I'm actually going to delete all this and just rewrite this part. So this part here, first we want to move the size of this message into RDX. So RDX will be 1 because it'll always ever only print 1. And what we could do is actually not, yeah, it'll always print 1. That's it. This brainfuck is just going to be really inefficient, and it is, because there's really no, everything you do in brainfuck is very difficult because there's no way to like remember stuff. There's no variables, there's not really any good control flow. And there's no way, like, let's say you store something in like cell 8, there's really no way of copying whatever is stored in cell 8 to another cell without doing like a bunch of work. Like you literally have to copy that cell into 2 other cells, and then the original cell ends up being 0. It's like a whole thing, and we'll get into it when we write our brainfuck compiler in brainfuck. But it gets very complicated to do very like simple things, which is why our brainfuck compiler will only compile to native, because keeping track of any state in that language is really annoying. And luckily there's not much state that we have to keep track of with the brainfuck compiler, which is kind of funny. There's really only 2 things we need to keep track of. So yeah, it's like it's the cell pointer and the pointer to the cell and the data itself. So yeah, okay. But even then, like, that's something that will be taken care of by the assembler. And if you notice here, I don't really need to, like, all this can be almost hard-coded. And so in the brainfuck compiler, all I really need to do is, like, if I find this, then print this. If I find this, then print that. And there's not much, like, the logic is pretty much that easy. So I'm hoping it won't be too bad. Okay, so let's continue writing this. So into, we're gonna use move instead of LEA. I'm not sure why LEA is used, but I don't wanna use it. So we're gonna put the address of, we're gonna put the value of cell I into RSI, and the value of cell I is gonna be the address of cells of wherever it's somewhere in that range. So that should be fine. And then the next thing we have to do is move something into RDI, which is 1. That's the STD out. And then another instruction here. We're gonna move 1 into RAX, just like that. And then we just have to do this syscall, and then that should just do it. So let's do instruction call syscall. Done. All right. Let's compile this bad boy. Sweet, and then now let's compile this bad boy. And nothing fails, so that should be good. And then test this DSM. So we move the cell. Great, 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 great. Add one, add one, add one, add one, add one. And if we check the bottom, that, yeah, this should be it. Okay. Let's see if we print A, guys. That's all I want to do. I want to print A. So we printed at. What's the at symbol in ASCII? Did I not do the right thing? ASCII table. So what's the at symbol? What's the at symbol? At is right before A. So this is working. It's just that I made a mistake. Like, I made a mistake. So if I go to... If I go to this, and I delete it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 30. That's 60. 1, 2, 3, 4, 5. So this should now, like, this should now compile just fine, and it's also should print A. We did it. We're writing native code. It's sick. That's really cool. That is really cool. So let's now check let's finish up our compiler then, because we can speedrun this now. So I actually want to know why this is being printed, because there's no new lines in the, there's no new lines. There's no new lines in my file, so I'm wondering why it's printing that. There. So let's compile, clear, and let's run this guy. Let's see what it's catching. Symbol is not implemented, and it shows nothing. But there's nothing. Can we get the character code for it, maybe? What was it that I was doing? It's not segment. I wanted to print the symbol. Okay, yeah. Symbol. Symbol's not implemented. Or let's see if that works. Let's build that. Yeah. implemented is 10, so it is the new line. And if we check SLPF, even though I haven't added a new line, I guess it just does so implicitly. I guess, right? Okay. So now we're gonna go back and finish up writing our compiler. So we got native plus working. Let's add native minus. Instruction call sub1 from where data pointer is pointing at, and instruction. Oops, I forgot the ending quote. Instruction. Ooh, what happened there? Call move cell I into RAX. And also, I don't know why it keeps doing that. It's so annoying that it keeps indenting. Like, I thought I specifically got like highlighting and stuff for this because like it would help. Okay, so instead of add, we do sub. Cool. And add one PID. So now we have the basic, like these basic instructions. The other instruction that we need to add is actually the input instruction, which I will have to look up how to do the syscall for that, actually. I think we had, I think if we go to our template.asm, no, okay, I think if we go to, yeah, here, we go to the examples and we go to lc hello.asm, we can find, okay, no, it's not there. Hello 64. Okay, here it is. So here's where our systems calls are in this folder. So let's do a quick check. Let's see what's in there. Source Linux include ASM x6a x76 64 and okay, I don't know why I did that. I'm gonna copy this. Oops. Oh my god, this is the thing that just closes. If I press Control Z, it just like nukes whatever I have open. And I keep accidentally pressing it. I don't even remember what I did. So nvim. Can I open this? Nope. Okay, so let's look at syscalls. For Linux, syscall. Maybe it's this. I have no idea, guys. I'm literally just kind of guessing. What the fuck is playing? Oh, I didn't realize this was a song I could just use on Twitch. I was like, oh, I've heard this song before. Skip though. Okay. Oh, Chromium OS docs. Cool. Oh, cool. It's right here. So read. We're reading the amount of stuff we're reading from. Okay. And I guess this is like the buffer it goes into. Yeah, because this goes into some type of buffer. Into the buffer. Yeah, I know what we're doing. Okay, cool. So we can just easily implement this syscall. Syscall, oh, that's read. We want write. We want to write to, I guess, this pointer. That's interesting that read is not const. And write is. Oh no, we are doing read. What am I thinking? What am I saying? We are doing read. We're not. We've done write. We are doing read. Okay. I don't know why I got confused there. So really, I just need RAX to have 0, 0, and then arg1 RTI that needs to have, what is this? Oh yeah, I guess this is the input, and I guess here standard input that will be there, and then the character buffer we're writing to, and then size count. Okay, this will always be 1. So this is relatively simple. Let's open up our. Actually, let's write a quick. I guess we could also write a quick test for our compiler with just what we have so far. And I did write a quick hello world program, but I cannot remember where I put it. I think it's A. Is it A.bf? I can't remember. I cannot remember. I don't think I did that. Okay, so I'm not going to even bother because writing a hello world program in Brainfuck is super annoying. So I'm just going to go ahead and whatever, I'll just write it real quickly. Why not? So let's do that, and I'll write it in very basic, in very basic Brainfuck. I'm not going to use loops or anything. So that's 65 at cell 0. Actually, let's try moving a cell, and then also trying to print it. I think like this should work too. Like just doing that should work. Symbol 10 is not implemented. Okay, yeah, we did that already. Yeah, I understand now. And this should still print, like this should still print A. Okay, good. But if let's go back to, what we're actually gonna do is we're gonna literally type, like, so that's 65 here, and we're gonna type, I guess, hello. So we need to know what's H. What's H here? L O new line. So it should just say hello now. This should work just fine in our compiler. So let's do that real quick. And if we find any errors, I guess we'll fix them. BF. All right, so obviously it's gonna print all that because we have a bunch of spaces and stuff. But it did compile, and it writes hello. All right, so we have we're almost done writing the compiler for Brainfuck. We're almost done, and it's only been an hour and 30 minutes, and I spent the first hour almost, or I guess, sorry, the first 30 minutes just figuring out how assembly works. So this is kind of exciting. This is kind of cool. We know for sure that like the data pointers are moving around in the memory properly because that's what it's just testing. So cool. It's really neat. It's really fun. Now let's finish this off. So we have to do the system call for getting something. So, and we're also going to, instead of doing this, we're literally just going to skip everything else. If it's not one of these symbols, we're going to skip it and we don't care about it. So here we will do the comma, right? And here what we need is, it's actually almost, it's literally the same exact, this is going to be the exact same. One sec. Get byte from std out or a store. Okay. And here what we'll do is print byte to std out. Okay. And so here, all we really have to do is we don't even have to provide like we can just pretty much copy all this, put it down here. And instead of doing RAX is equal to 1, it's equal to 0. That's literally it, because it's using the exact same argument. So this is going to be the size. This is going to be where we're storing a thing. This is going to be the standard, like the input we want to get it from, and this is going to be the type of function we want to call. So there it is, syscall. So we've just implemented the quote key. That's easy. And now let's write another test program. So test2. Actually, this will be input.br. So this will do that. Let's write test. Let's make test.br. Let's rename that to hello.br. Okay, so now we have those two, and I'm gonna go ahead and remove test.bfasm and remove test app. Okay, so now we're just left with that. I'm also gonna remove this template symbol thing. I don't think we actually need that. And I'm gonna remove my to-do list. That was from last time. And I think that's it. I think we have everything we want. I'm gonna remove a.bf as well, just because it's not something that I it's not something that I need anymore, so I'm gonna get rid of that. But something I do need to do is, well, now I finally have to, I'll re-add in comments in a second, but now I finally have to deal with the loops, and that should be kind of interesting because I have to actually work with jump statements in assembly, which I have no idea how to do yet. So I guess we're gonna figure that out as well as we go. Okay, let's open back up. Let's open this back up. Oh, actually, we need to test if the input works. So I forgot that's what I was doing before I renamed everything. So all I actually want to do is that whatever I type in, I wanna print it out, and that's it. So let's try that. Let's try to compile this. So let's make sure we're built. Crystal build bf.cr. I spelled crystal wrong, didn't I? Yeah. Okay. That's good. And then now let's try to compile this. And it compiled just fine, it seems. And now let's check it for... So here we do get byte from std out, store at dp. And then we print it. And then we're done. Oh, I forgot to do this. I forgot to indent these, which I'll do in a second. I think I actually just totally forgot. Actually, let's do a quick run on this guy. And so if I type in O, prints O. Perfect. So let's open up Brainfuck again, our compiler, and let's go to near the bottom where I forgot to change all those print calls. Yeah, right here. So let's call that file print. Oops, that instruction dot call. And here we will remove the bracket, the ending bracket, and we will also remove the new line. There we go. So that should be good. And we have to make sure to set the indent here to 0. Cool. Oh, and I forgot to add a space, so let's do that real quick. I think that's there. Cool. All right. So we're almost done. Now we have to add the loops and the labeling. So we have 1, 2, 3, 4, 5, 6. So we have 2 more instructions to go, and then we have the comments, and then we'll be done. I guess I will implement the comment right now because I don't want to worry about it. And I want to be able to add comments already. So if we see this guy, we're gonna increase the instruction pointer by 1. And then while program IP, actually we'll do this until program IP is equal to this. Then we'll keep looping around. We'll literally just keep at 1, and then by the time we're here, we want to go outside of it. Cool. So that's literally how we implement the comment. That should be fine. Let's give it a quick test. So we'll test it in our hello.br. So this is going to be H. It's going to be E, L, O, and new line. And actually, we don't have to get so crazy with the comments here. So let's try to compile this now after we build. So crystal build df.cr. Let's do that. Clear crystal. Oops. bf. Try to compile hello.br. Oops. hello.br. And that seems to compile just fine if we call it. Cool. So it's still working just fine, still doing what it needs to do, still doing what I thought it would. Something I also wanted to try out now that we're here is we're going to actually, because the input is so ugly, the input BR is so ugly, we're going to also, what is this? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We're also going to print a new line here because that's useful. So print first input byte print new line. Okay, so if we do that now, .br, after compile it, and if we run it and we type in s, prints s, or it prints. Interesting. So I'm thinking it's because there's s in the that original input section. So we're pretty much adding 10 to s, and that'll equal some random ass thing. So let's call this up again, and I'll put an f. Oh, interesting. So it's interesting. So it's this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 1, 2, 3, 1, 2, 3. Why did it print out? Oh, that's weird. Why is it printing out that? That's so weird. What am I doing wrong? Is it a problem with my compiler? It's weird that it's printing that out. It's weird that it's printing that bar or something out. That's weird. So let's go into here. Yeah, we move the data pointer. Add 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we print it. Does this work like that? I have to do this. Yeah, I have to do that because every time we encounter, actually this wouldn't even work now that I think about it. I would have to do that. So that should work. Does this at least print out a new line? I actually don't think I compiled it. I just realized. I don't think I compiled it. I just realized that. That's what probably was wrong. That's probably what was wrong. I didn't compile it. Okay. I was worried there for a second. Oh my god. Jeez, I thought I was like something was wrong. Okay, I didn't want to go through that again. All right. Let's play around with looping now. So easy peasy. So let's go back into this, and finally let's implement our looping instructions. This is cool. I kind of like working in x86 64. It's kind of fun to figure this stuff out. So let's do the open bracket, and let's also just right away do the close bracket. Okay. So in the close bracket, we actually don't need to do the simulated thing that we do in the interpreter. What we can do instead is just assume there's a label to jump to and jump to that layer. So one thing we're gonna have to do is actually keep track of. We're gonna keep track of the labels we have. So we have to go up here and we have to do bracket level. So each bracket level will have a different like jump code to it. So starting at 0, maybe it'll be, well, maybe we'll call it something like jump label A when it's at 0. So when we first encounter a bracket, we'll increase this, and we will write like a function. We'll write a label that we assume exists and jump to it if it's not equal to 0. So like whatever the data pointer is pointing to. So we're gonna have a bracket level up here, and every time we encounter an open bracket, we're going to increase it. So bracket level plus 1. So that's actually after we process it. So right now we're at bracket level 0. And the thing is we have to always remember that this is going to be written in Brainfuck at some point, and therefore we can't do anything complicated when creating these labels. Like, these labels need to be like unbelievably easy to calculate. So I'm thinking we're only going to have we're only going to allow, like, let's say 52 jumps, or sorry, yeah, 52 jumps, because there are 26 letters in the alphabet. And what I'm thinking of doing is I want to label the labels by the letters of the alphabet. And so what we can do is the first label will be label A, the second label will be label B, it'll be then label C all the way down to Z, and then it'll be label A capital, label B capital, label C capital. And so we're going to use all those like numerical, and we could even use 0 to 9 as well. But for now, we're just going to use A, B, C, D, E, F, G. And the reason for this is because constructing labels, we need to construct the labels in a way where we need to keep track of which label we need to write in Brainfuck. And this is like by far the easiest way to do it, I think. Because in Brainfuck, I think we could easily sort of keep track of a bracket level, and this bracket level can easily be converted into a letter between 65, which is the decimal code for A, all the way to whatever the decimal code is for Z. And it should be like, we should literally be able to move the data pointer to the bracket level, copy it to another cell, and then add that to 65, and then we should be able to get the suffix for our label, which, yeah. So let's do that. Let's get the suffix for our label here. So the suffix for our label is going to be a dot ord. Oh, my stream is... My stream went down. Let's see. I don't know if it's going to go back up. Waiting to see. No internet connection. Attempt to reconnect. Reconnection successful. Okay, I think we're back. I don't know what happened there. I think it was like an internet hiccup. Hopefully it's not too bad in the video, but it doesn't matter because it's gonna be all edited and no one's watching right now anyways. There's literally 0 viewers. Okay, this will all be in a video. So we're gonna do suffix A. So that's we're gonna convert that to its ord, and then we're gonna add the bracket level. And I think, yeah, A is like, capitals come before the lowercase, I think. So let me look at that real quick. ASCII table. So yeah, so here are the capitals, and they come way before the lowercase. Oh, what sucks though is that there's stuff in between. Like, I thought I would just be able to keep adding 1 and then get to these, but there's stuff in between, and these are definitely not allowed. Well, maybe the underscore, but these are definitely not allowed. So we're actually gonna only allow for 26 loops, which I'm not sure will be enough to compile itself. But for now, I mean, we'll have to write. Oh man, it's gonna suck. But I guess what we could also do is if we go past 26, then we can wrap around. I guess we could have two letters, so we can always have, yeah, we can have two letters, I think. But the issue is that we'll always have to check if, man, it's just doing anything complicated in brainfuck is gonna suck. So I'm thinking, let's try. Hopefully, we won't need more than 26 loops. I think 26 loops is a lot. We shouldn't need more than that. I'm hoping we don't, because otherwise the compiler won't be able to compile itself, and that would suck. Okay, so let's do that. Let's just use 26, and hopefully that will be that. And the assumption will be that we have 26. So yeah, so instead of that, we're gonna add bracket level like that, and then we're gonna do what we did before, which is I think unsave char. There we go. So that should convert it back into some letter between A and Z if we have less than 26 of them. So something that I probably want to check is if we have more than 26. Well, maybe we can write an error here. So I'll do it as a to do because I don't want to do it right now. But to do basically abort if bracket level is greater than or equal to, it's greater than 26. There we go. So if it's greater than 26 letters, then we know, yeah, so sorry, greater than 25 because we're start at 0. But if it's greater than 25, then we need to abort because there's just not enough. Yeah. So now that we've done that, we're gonna create our label name. So our label name is going to be BR. Yeah, BR jump. Yeah, let's just do BR underscore. Or just jump underscore. That should be fine. BR. I like BR. And in here, we will put in the suffix. Okay, so now we have the label that we assume exists. And here, we can actually create that same exact level. So if we do abort bracket level data, suffix is going to be the exact same thing as above. So it's going to be a, it's ordinal plus bracket level dot unsave char, and then the label name is going to be br suffix. Okay, and then the bracket level is going to go -1, and this is going to be +1. We also need, the other thing is that we need to actually jump back up to this label. So we really have less, we have less loops than we think we have. We actually have, I think, half. We have 13, I think. And the reason is because the closing brace, the closing bracket needs to be able to jump back up to the open one, and the open bracket needs to be able to jump down to the closing one, to the closing bracket, so after that. And that is not really possible with a single label, obviously. So we'll need two. And the other way of doing this would be to do relative jumps, but this is also not possible because if we do relative jumps, then we'll need a way to find the how far away the other bracket is, and that's just, we're just not gonna bother doing that in brainfuck. Like, fuck that. We're just not gonna do that in brainfuck. We're just not. because that would suck. So we are probably going to be limited to 13 loops, which is very low, but this is also a compiler for writing a compiler. So yeah, so let's keep going. It's been 2 hours, it's been too long. I actually do not know. So it's been 2 hours. I'm gonna do until 10 max, and hopefully we'll have something by then. So let's start writing stuff. So we know at some point I'm gonna want to have my label name, and the label name will have to have a colon here. Yeah, so that'll tell me it's a label. And this will just be indent equals 0, and then after this, indents. Okay, so what this will do is we'll set the indents to 1. We'll 0. We'll move it back, so it's just like on the very back of the code, and then we'll set it back when we want to do that. When we want to, since we want indents on the preceding code. So this is the label name that we're going to be calling back to from the closing brace. So we need to we need a way to derive that from this closing brace here. So here's the suffix for the closing brace, and this needs to actually jump up. We need two two labels. My label, which will be where we're at now, and we'll make the suffix. The suffixes will be just right beside each other, so it'll be B, the ordinal of B instead, plus bracket level. Sure. Suffix 1, suffix here, suffix jump. So we're going to be jumping to B, and we're called A. So where we're at is called A. And the first thing we have to do is label here and suffix here. And instead of just doing that in here, we're going to just go ahead and inline that. Oops. Copy this. I don't know why I did that. That's really annoying. Thank you, Vim, for doing that. Okay, so suffix here, and then we need to, and then when we jump, we have to jump to suffix jump. Okay, so the first thing we have to do is instruction.call. We need to move something into RAX. Actually, we'll move it into RBX. So we need to move whatever's in cell I, so the address of cell I. So whatever the cell I is pointing to, which is the address to cells, we have to move that into RBX. Then we need to move whatever value is in RBX to RAX, like this. So the value now of that location in memory is going to be in RAX. And then finally, we're going to call the instruction call compare RAX with 0, right? And we're going to do the jump instruction that jumps if it's equal to 0. So if we're equal to 0, then we're going to jump to, you guessed it, we're going to put that in here, ER underscore, I'm going to do another one of these, and then inside here, suffix jump. Okay, so that should jump from the open bracket to the closed bracket if the value at the current place in the data pointer is 0. So that should be fine. This next one here is going to do the same thing. So this is going to be suffix jump, and this is going to be suffix here. and this will begin like that, because this is referring to where we want to go back to, and this one's referring to the one that's actually that we're sitting at right now. And because this code is so similar, I'm going to delete that and just copy all this. And there we go. The issue is that we actually do not add +1, we have to add +2. And the reason is because now we're using up two spaces here. And that's precisely why we're going to only have half jumps. So we're going to do the same thing here. We're going to move whatever's in there, okay, into here. And this is going to be non-zero. So if these aren't equal, then we jump to suffix jump. And I think that makes sense. And I just realized, man, this needs to change here. Level. Did I write? How did that? It's weird that I changed from here to here, because I thought I copied and pasted, but I didn't. Okay. Yeah, I didn't copy and paste. I just remembered. So that should be it. I think these are the jump instructions. I think that's all we need. And it's like I keep looking at this and thinking like, man, why is it so simple? Like why isn't there more code to this? But we're also writing a language with 8 instructions, and the instructions do very simple things, so it really should be this simple. Alright, so let's try to compile this now, and we're going to do a simple loop check here. So our loop check is going to be super simple. We're going to print A in a loop, and we're going to do the same thing we've done before. So we're going to start off with 5 here, and inside these brackets we're going to move 1 to the right, and then we're going to add 13 there. So 1 2 3 5 1 2 3 5 1 2 3. We're going to move back, we're going to subtract 1, and then we're going to close that. Then we're going to move back to the space that we actually want to print. We're going to print that, and then we're going to print a new line, just so, and we have to move 1 more, just so it's not in the same line that we run this at. So let's close this now, and let's compile our compiler, and let's run it. So this should be C, and this should be loops. Undefined symbol B. Okay, so let's check what's wrong in the AS BRA. We're trying to jump to BRB. Where's BRB? Oh, you know what we didn't do? I think we didn't, like, we don't, oops, I don't want to open that. I don't think we, why is there so many? I don't think we put a label for it, actually, now that I think about it. So we put a label for A, but not for B. So let's go here, and here's this here. We didn't copy this, I think. Did we? No, we didn't. Yeah, so we have to do that. So put that in here. It's weird that it didn't give me like an unused like error, but this should do the exact same thing. And actually, this should be after this. So we want to actually teleport to. We don't want to do this comparison. We want to teleport after it. And the other one so yeah. So once we reach this instruction, we do this, and yeah. So once we reach this instruction, we jump back if necessary. Otherwise, we put down the. So this will just be there. Okay. I think that should work. Build that. Clear, and let's run this guy. Undefined symbol BR. Why isn't it writing it? Why isn't it writing it? Check it again. BF. Okay. Okay, BA. So BRA, that's fine. Subtract 1. E. Why is it a D here? Why is this D? What? Why is that D? Why is it C? Oh, I know why. I'm freaking dumb. I'm like a very dumb guy. My bad, guys. My bad. It's because we... Oops. So it is because we have... Go here. We have to do this before this. There we go. So now let's try one more time. So we have to build our guy. And then we have to try building it. So that passed. And now let's check loop. Oops. Loop.asm. And so we have BRA. And that's before we do the check, which is good. Actually, this should be after. This should be after the check. Let's do that. We also didn't add the new line to our most recent instructions, so I'm going to do that as well. Just take this guy, and we're going to add it back here. And this instruction here actually needs to be after this. And yeah, should be like that. Because we want to jump, when we jump back, we want to jump after we do the checks. So yeah. And it's the same thing here. When we jump to here, we want to do it after these checks. So we're not even checking that. I think that's it. Oh yeah, totally. I almost forgot to do the exact thing that I wanted to do before. Moving on, do that. And let me just make sure that all of our instructions have a new line. So this one isn't needed, obviously. There's no instructions being created. And yeah, okay, cool. So let's do that. Let's build it. Let's call it. That works just fine. So, pretty good amount of bytes, I think. Actually, how big is it? Loop.asm.out is 100,000 bytes. I wonder how big that is. Oh, it says right there, it is 16 kilobytes of memory. That seems like a lot for what we're doing, but for whatever. So let's make sure our loops ASM is fine. So we do this, then we have our jump equals. This is BRA, and if we go down here, we have BRB, and we have the BRA if we get to here. And we forgot to put a comment for these guys to label them. So we're going to do that before we do any testing. We're going to add that little comment on top of everything to our loops. So add that here. Loop if 0 b closed bracket. Loop jump to grab it if 0 at dp, and here we'll do the exact same thing. Loop jump to open bracket if not 0 at dp. Okay, and compile this guy again and run it again. Neat, fine. And one more check. Loop.asm. So we have that, all these. We have loop jump to close bracket if at 0 at dp. That's good. And we have loop jump to open bracket if not 0. Okay. Cool. So as you can see, something that I want to also point out is that actually let's quickly run the loop. The loop should print A, right? And it's stuck forever. No, we're gonna be here forever. I just want this to work. We spent We spent 6 hours on this, I think, in total. In total. Um, damn, I thought that would be fine. Damn, I thought that would work. But I also kind of want to check if this loop runs fine. I want to check if this loops runs fine in my, like in the interpreter version. So if we run loops bf, oh, br. If we run loops bf, like that does, okay, so that works. So something's wrong with the way we are doing the loops. Okay. Hmm. Hmm. Mm-hmm. I think it's doing it. I think that was it. We did it. It prints that. Now we can do the loops example. Forgot what that print, but I think it's like that. Yeah. And there we go. Finally, after this was a 5-hour stream, I think, and I finally figured out how to compile this all in native. It took 5 hours to do this in Brainfuck, and that's because I literally spent an hour trying to fix this last little loop thing. Like I understand the logic behind everything, but I could not understand like how to like I didn't understand. There's so many little things that I just couldn't understand why they weren't working, and so yeah, I guess that's it. I think I should probably be more careful about how I write my instructions because right now I'm using R like the 64-bit registers for everything, but I should really be trying to use the smaller ones, I guess. But I'm not really sure. I'm not an expert in assembly. Obviously, I just started using it, so hopefully, if these videos get popular, someone can correct me how I'm actually supposed to do things and why things weren't working originally. So that's basically it. I'm super happy that my Brainfuck compiler now works and it runs in native. In the next stream, I will be implementing some very simple optimizations for our Brainfuck compiler. So it'll be things like being able to optimize. First, we're going to optimize like consecutive pluses. So if there's like a bunch of pluses, we're not going to just add one to our. We're not going to just add one to our thing. We're going to add as many. We're gonna like basically do like a run. What is it called? It's like an encryption method as well. It's a run length encryption and just count them. The final thing we'll do in the next stream before we implement the Brainfuck compiler in Brainfuck is we will be writing a helper print function that will take in a string and then print out the Brainfuck for that. And it'll try to do it in an optimized way, so it's not just like 70 pluses, 60 pluses to do like the ASCII characters. It'll try to like figure out like the best way to do the loops for it. All right. Good night, guys.